morning, my dear students and dear parents, and a very warm good morning to all my colleagues who have joined on Zoom. It gives me immense pleasure to be able to talk to all of you regarding the facilities that we have at DBIT and regarding mechanical engineering itself as a very interesting and a very core branch of engineering. So let me start off by taking you through what mechanical engineering is all about. So let me start off by looking at what mechanical engineering is all about. So I will start off by titling the entire presentation as Mechanical Engineering from Core to Cloud. Now, as young aspirants of engineering, and this goes to all my students as well as to the parents, as young aspirants of engineering, what is it that students really want to do? What is that they aspire for? I think one thing that you all aspire to do is probably, number one, you want to design the next big idea on this planet, right? That is something that everyone aspires to do. You also probably are wanting to build a unicorn, because today parents and children are looking at reading about unicorns every single day. So what exactly is a unicorn? A unicorn is essentially an organization which has got a valuation of about $1 billion. And you are probably aware of several unicorns like Byju's. Do you know that Byju's was built by Baiju Ravindran, who is actually a mechanical engineer? Yeah. So you also have unicorns like Zomato, you have Paytm, and so on and so forth. So I think young engineers always want to design the next unicorn. Another important thing that we all want to do is we want to save the planet, right? All engineers are trying to save the planet, because each day that we read the newspaper, we are looking at so many issues which are there. As far as the planet is concerned, sustainability is a big issue. The conference of parties which was held has been in the news for so many reasons. But on a more realistic note, probably I think what engineers want to do is you want to solve the problems of the world, right? You also want to be an inventor, or you want to become an innovator. You want to start an enterprise, become an entrepreneur. You probably want to do cutting edge research. This is something that young engineers always want to get into. You want to probably work in a multinational corporation, or you also want to study abroad. So with all these aspirations, young engineers try to get into engineering, and parents also try to get their children into engineering. So let us look at what are the factors which motivate a student to take up a particular branch of engineering, right? There are so many factors. I think the most important factor is passion. Do you have passion for a particular branch of engineering? This is the most important factor, and it is passion that drives us towards taking up a career in our lives. The second one is, which probably parents and students are all looking at, is what is the kind of pay packet that we have? Which is the branch of engineering, or which is the profession which is giving us very high pay packets? Then something that we also try to look at is future prospects. Does a particular profession that we want to get into, or an engineering discipline that we want to get into, does it have future prospects? Then a very important factor, which probably we may not be willing to attribute to, is herd mentality. Is there a herd mentality? I mean, are we all trying to follow a herd and get into a herd mentality? terms of we always try to do what, people who are with us are getting into. Parental pressure is also equally important because parents always want to get their children into, a kind of profession which probably secures their future. And therefore, parental pressure is very, very important. Okay, so we were looking at what are the factors which decide why somebody gets into a profession. I spoke about passion. I spoke about pay packets. We looked at future prospects, herd mentality, job security. Parents are always wanting to get their children into professions which are secure, which give them a secure future. Peer pressure. Sometimes we find that many of our friends are getting into a certain profession and therefore we all want to get into it, right? What is also equally important is parental pressure, because parents' concern is always going to be there, and that is an important parameter. Sometimes we get into a profession simply because we have got a seat. So there are several factors which motivate us behind taking a particular branch of engineering. But now the question is that, okay, how do I really choose what is the branch of engineering that I want to get into? So what are the popular branches of engineering that we have? One of the popular branch that we have is aeronautical engineer, because aeronautical engineering tends to fascinate children from a very young age. Biomedical engineering, very interesting field of engineering. Computer science, very, very popular today. Then electronics. Then electrical engineering, extremely relevant even today. Instrumentation, information technology, mechanical engineering. But of the factors which I have mentioned to you, is decision making sufficient based on only these factors, or are there also other important parameters we need to consider? So let us look at some other important factors which we also need to consider when we are choosing a branch. First and foremost is that every branch of engineering that we choose to get into has to be founded on fundamentals. There must be a fundamental knowledge on which the entire branch is built. Then it is important for us to understand that is a particular branch of engineering applicable in how many areas? How much of applicability does the branch have? How versatile is that branch of engineering? Which means how much of freedom does it give you in order to grow as an engineer? Does the branch of engineering also teach you important skills? Because there are several important skills that an engineer should be knowledgeable about. And very important is that engineering is expected to be, supposed to be that branch which is solving problems. And today we know that the world has innumerable problems that need to be solved. So do these branches of engineering give us the skills to be able to solve the world's problems? And also, does the branch provide us with a lot of flexibility? For example, having learned in a particular branch of engineering, do I have the freedom to move into other branches? Is it versatile enough? So just as our passion is important, job prospects are important, career prospects are important, it is also important for us to understand whether the branch of engineering has a lot of applicability. Is it versatile enough? Does it train me with adequate skills that makes me a lifetime job creator or a worker? Does it solve the world's problems? So these are equally important. So therefore, when we are looking at engineers as those people who are going to solve the world's problems, it is also important for us at this point of time to find out what are the global problems that the world is facing today. We read about it every day in the newspapers. There are problems, but we also need to find out who is going to solve these problems. So what are these problems? Number one, global warming. This is a problem which is going to impact the future generation like never before. Shortage of potable water. Every day we tend to face this particular problem. Minimum basic health care for everybody, an important criteria on which Governments win election and also lose elections. Access to education for everybody. Poverty. Poverty is one of the biggest problems of the world that has still not found a solution. Explosion of population, accessibility of energy. You know, we are talking about the energy targets for every country. Therefore, how to make energy accessible to everybody is going to be a big problem, because there are countries which are developing which need a lot of energy. And how do we ensure that energy is available to them? Depletion of natural resources, very serious problem that we are facing. Shrinkage of the groundwater level, providing livelihood skills to people so that people are able to fend for themselves and they become, communities become resilient. Pollution, you know, a problem about which we read every single day in the papers. Hunger. So these are the current global problems, and whichever part of the world we are in, whichever community we are in, whichever profession we are in, let us understand that we are all contributing to the problem. So we also need to solve these problems. But can these problems be solved by only fundamental knowledge, or do we need more information to solve these problems? So let us try and look at these problems in common. First thing that we have is that none of these problems have a single unique solution. For example, if you want to end hunger, the solution that you are using in a country like India is going to be very different from a solution that you're going to use in a country like Africa. Then, if I look at these problems, you will notice that these problems do not belong to one particular domain or one particular branch of technology. In fact, they don't even sometimes belong to technology alone. If you are looking at livelihood skills, you have economics coming into picture, you have skill development coming into picture, you have technology coming into picture. If we look at these problems, they require multidimensional skills. For example, even if we look at education, you need information technology, you have civil engineering for creating the infrastructure, you have mechanical engineering requirements, and so on. And these solutions are not short-term solutions. For example, the problems are so important that the solutions will evolve over a period of time. And also, these problems are dynamic, and the definition of the problem keeps changing from year to year. So when we are training youngsters to get into a very challenging world where they have all these problems to solve, what are the kind of skills that we need to provide them with? This is what we will look at. So these we define as the 21st century skill set. So if I look at the 21st century skill set, we have certain very fundamental or basic skills, like for example, literacy, basic fundamental concepts of any subject, numeracy, understanding numbers and mathematics, scientific literacy, which is the whole idea of wanting to analyze a problem, understand a problem and analyze it. Computational literacy, fundamental for solving every kind of problem. Financial literacy, to understand what is a good solution. Does it make economic sense or does it not make economic sense? Cultural and civic literacy, because every solution has to be identified with a particular culture. In addition to this, iske bawajud ya iske alawa, we also need certain special skills. For example, we need to be creative thinkers. We need to have problem solving abilities. We need to be creative in our communication with people. We also need to work in collaboration. So being just an individual, hardworking engineer doesn't really work for many problems. You need to know how to collaborate with individuals. In addition to that, certain skills that we really need to have, and we need to carry this forward for an entire lifetime, is curiosity. You know, how curious are we as individuals? Initiative. Do we have the capability to take initiative to solve a problem, or are we just waiting for somebody to come to us with a problem and solve it for them? So taking initiatives is very, very fundamental. Persistence. As I said, many problems require solution over a period of time. Therefore, do we have the persistence to continue with that problem? Then adaptability. Are we willing to adapt to a problem, or are we saying that I will only solve a problem which is in my domain? So therefore, our ability to adapt to different technologies in order to solve a problem, our ability to be a leader and say that I will take charge of this particular activity, and our social and cultural awareness. So if you look at the 21st century problems, they require a completely different kind of skill sets. And these are all the skill sets that I have spoken to you about. But what is important for us to understand is that these skills are independent of the basic domain knowledge. They belong to all the domains. So whichever domain you are in, you need to have these skill sets. So what we have done right now is we have looked at 21st century problems. We have also looked at 21st century skill sets which are required. And I am now going to put forth to you what is it that mechanical engineering is able to bring to the table. So let me look at the uniqueness of mechanical engineering as a branch of engineering. First of all, it is based on fundamental engineering knowledge, absolutely fundamental knowledge. So we have the laws of thermodynamics, we have the laws of Newton, we have the Navier-Stokes equation. These are all based on fundamentals of energy, fundamentals of motion and momentum, and so on. The curriculum of mechanical engineering is very broad because it encompasses so many areas, but also at the same time, it is very deep because it gives you an in-depth understanding of several aspects. So there is no superficial treatment in mechanical engineering. Mechanical engineering, we say, is very versatile because it has application in practically every field, whether you're looking at health, whether you're looking at education, whether you're looking at manufacturing, it has got its application in every field. It is very adaptable because mechanical engineering has been able to embrace new technologies, and all these technologies are now available in the core mechanical engineering curriculum. Mechanical engineering is also very flexible. That means we look at core engineering, which is all about machines, mechanisms, energy, but it also looks at applications which are in the cloud. So everything that is related to artificial intelligence, data sciences, machine learning, there also you have core mechanical engineering applications and requirements. Mechanical engineering as a curriculum is also very practically oriented, and it is application oriented. So there are a lot of practicals in the entire field which give you a lot of skills to work as an engineer on the field. So beautiful factors which are there as part of mechanical engineering. If you look at the subdomains of mechanical engineering, it is, we all know, one of the oldest branches of engineering, started way back in the early 17th century, but is equally relevant even today in the 21st century, and will continue to be relevant for several centuries in the future. Probably not in the current form, in a different form, but the relevance will still be there. So it's one of the oldest branches, and it is called as the mother of all engineering branches. It is a core branch to a host of industries. Like, for example, obviously, manufacturing is something that we are aware of. Automobiles cannot exist without mechanical. Space technology, marine technology, energy. Today, we are looking at energy, renewable energy sources, absolutely in mechanical engineering. Machine building and design, aerospace, one of the most fundamental branches, offshoots of mechanical engineering. Construction requires a lot of mechanical engineering along with civil engineering. Pharmaceuticals, all the machines which are used in pharmaceuticals are based on mechanical engineering concepts. robotics, most relevant branch of engineering today, automation, design of defense equipment based on mechanical engineering, petrochemical units, fertilizers, farm equipment, transportation, water supply. The list is virtually endless. I have put in probably only 20 to 25, but the list is absolutely endless. Let us look at some of the emerging fields of mechanical engineering. As I said, mechanical engineering is very adaptable, very versatile. So what are the new areas? Green manufacturing. How do we minimize the use of resources, any kind of resource in manufacturing? That is all what green manufacturing is about. Biomimetics, which is about how to mimic nature in the design of whatever processes, systems, products, etc. in engineering. Biomechanics, smart materials, smart factories, additive manufacturing, which is also called as 3D printing, self-driven vehicles or driverless vehicles, space technology, very relevant today, robotics, nanotechnology, drone technology, industry 4.0. So here you can see that mechanical engineering has kind of metamorphosed into so many other branches, and it has tried to gain a foothold in practically everything, right from core to cloud applications. So if I look at the career path of a mechanical engineer, the career path can begin from being in fundamental areas like sales, marketing, design, development, entrepreneurship. Core fields like automobile, space technology, manufacturing, robotics and automation, smart manufacturing, biotechnology. You could choose to become a mechanical engineer in this area. You could be a mechanical engineer in simulation and information technology, probably in finance and operation management, core research and development, and in Indian engineering services, military engineering services. These are again areas where a lot of mechanical engineers are to be found. So if you look at the career path, again, it encompasses everything from core to cloud. Now let me come to the mechanical engineering department of Don Bosco Institute of Technology. You have already seen a video wherein we have tried to show you what are the best aspects of mechanical engineering. We have a very sound foundation in mechanical engineering in terms of the variety of laboratories that we have. We were able to give you a glimpse of only a few, but maybe you should visit our campus to see what more we can offer. So in mechanical engineering department of DBIT, we have minimum internship of 30 days that we assure every student getting into this campus of. There is project-based learning, which is very fundamental to core learning right from the first semester onwards. We ensure that our students are trained in core skills as well as in life skills, in computational skills through mini projects and major projects, right from the first year onwards. We have top-class faculty and extremely well-equipped labs, excellent employment opportunities. You have already seen in the video. We have all the top manufacturing companies as well as IT companies recruiting from mechanical engineering. There is an opportunity for every student for her holistic development on the campus. We also provide every student with minors and certifications and several value-added courses. And all these are based on what the industry requirements are, so that every student who graduates from this department is able to take on challenges in an extremely challenging environment which is there outside. We also have our students participating in national and international competitions, and you have also seen glimpses of this. So Don Bosco Mechanical Engineering provides an opportunity for students to grow not only as very skilled mechanical engineers, but also to develop an entrepreneurial frame of mind and to become lifelong learners and self-learners. This is the kind of environment we try to create in the department. And not only in the department, in the entire campus. You have already looked at some of our labs. So our thermal engineering lab, 3D printing, which we have, fluid mechanics lab, computers lab, workshops, internal combustion engines, and a variety of labs. So now if I try to talk about what the mechanical engineer of the future is going to be all about, number one, she is going to be all about being comfortable in specific domain knowledge of thermal and fluids, design and manufacturing, and its application. So core understanding of the branches of engineering, of the branches of mechanical engineering is going to be very important. She is going to be equally proficient in software and in conducting simulations because this is a part of the core curriculum. She will be confident in conducting research and development. We ensure that there are a lot of opportunities in the campus itself for this, to be able to develop innovative solutions for sustainability and to become an entrepreneur. So the mechanical engineer of the future is going to have a lot of challenges on her hand, but she is also going to be well trained to ensure that she is able to surmount all these challenges and look at all these challenges as opportunities to grow as an engineer. Some of our very notable mechanical engineering graduates you have already seen. I'm very proud of them because they are from our first few branches. Joshua is from our first branch of mechanical engineering. He is with Airbus in France. Dr. Gavin is from our second branch of mechanical engineering. He is already with the US Food and Drug Administration. Shraddha, we are very proud to have a young girl student in the Indian Navy. Aaron, who has made us proud by being with ISRO. Vikas, who is with the Indian Engineering Services and in the Ministry of Defense. So in conclusion, I would like to say that you are all welcome to the mechanical engineering fraternity to enjoy a very challenging and a fulfilling career. I thank you all for being a part of this webinar. I'm sorry for some of the minor glitches that we had, but I hope you got the essence of what mechanical engineering is all about and what DBIT has to provide in terms of mechanical engineering. And I wish all of you the best. So once again, my suggestion to all parents and students is that whenever you are thinking of a branch of engineering to get into, understand what are the prospects that it offers you. Please do not simply be convinced by by what others tell you, by what your peers tell you, and don't have a herd mentality. Evaluate every branch of engineering to see what it can offer you and what is the kind of challenging and fulfilling career it can provide you with. So with that, I conclude my presentation. And thank you very much once again for being a part of it. I would like to thank all my colleagues of the Mechanical Engineering Department and of DBIT for having helped me in prepare this presentation, for having been useful in preparing the presentation and also critiquing it whenever required. So thank you once again and all the best.
One question that has come through the chat is currently in industry 4.0, everything is moving to IoTs and the virtual platforms and everything. So what exactly will be the role of mechanical engineering in industry 4.0?
Okay. Okay, so industry 4.0 is all about connectivity, right? It is all about connecting machines so that the machines are able to talk to each other, and it is all about a very seamless process of production, right? So though everything is moving on to the cloud, the fact remains that the industry still needs to produce, it needs to manufacture. So you need to have manufacturing processes, you need to have raw materials, you need to have products. And in order to do that, you need to have designers, you need to have production engineering, you need to have very high-end machines which are able to take on these very challenging aspects of manufacturing. And I think that is where the role of mechanical engineers will come, because the very fact that we are talking about manufacturing means that it is very important for the mechanical engineer to be able to work in these fields and ensure this seamless connectivity. It cannot be done without mechanical engineers.
Madam, one question from me. Actually,
Yeah.
this is one of the participant also put in the chat, and this also similar to my question in my mind. So how the girls are comfortable in mechanical engineering? Because it all about the machines, it all about power plants, etc. Can you explain that?
Okay. I think probably I am a living example of why girls should get into mechanical engineering, considering that I graduated almost 39 years ago. Yeah. Let me tell you that, did you know that Kalpana Chawla was a mechanical engineer? Huh? So yes, there are plenty of girls who are into mechanical engineering. And I think earlier, probably women were not very much encouraged to get into mechanical engineering, primarily because of the culture was a shop floor culture. Yeah, and where you had to work with machines, you had to work with workers, and probably it was not a very comfortable environment. But I have worked in those kind of environments, and let me tell you, it is a wonderful environment to work in. Probably if you have a passion for that. But today, mechanical engineering has in fact gone into so many areas where you are not really required to be on the shop floor. So you have fields like design, you have simulation, you have planning and processing, you have purchase, you have sales and marketing, you have research. So there are innumerable areas. And let me tell you another thing, which is something that I learned. I feel that the presence of girls in mechanical engineering is very, very important, because women can bring in that kind of sensitivity and empathy, which is very, very important in workplaces, and also that sensitivity in product design, which can make products which are universally applicable. Because sometimes we find that products which are designed can be a little non-inclusive. Women are important in these kind of places. And as a mechanical engineer who has also been in the industry, let me tell you that it is an absolute safe place for girls. And it's a wonderful place because it has as many challenging opportunities and as many success stories as you can think of. Some of my idols, people whom I look up to, are lady mechanical engineers who have done a wonderful job in the industry and elsewhere.
Yeah, ma'am, the next question in the chat is, in current mechanical engineering domain, which if we talk about, the current job prospects in the market are moreover in the areas of programming. So the job is kind of a job they are doing is a kind of as a software engineer, but so does mechanical engineering new syllabus and curriculum has equipped with these kind of skills or not?
Okay. See, first of all, I think, when we are looking at some of the very, very big ambitious plans of the government of India and of our Prime Minister, especially when we are talking about becoming a 5 trillion economy, and we are looking at Make in India, we are looking at manufacturing in India. Remember that India can become a 5 trillion economy only if it ensures that it has a very strong manufacturing base. Today, China is able to lead the entire world because its manufacturing is extremely strong. So manufacturing always remains core for the growth of an economy, and especially a developing economy like ours. So it's only a matter of time that India is going to step up manufacturing in a very, very big way. Yeah. Now, having said that, so therefore, lot of relevance for mechanical engineers, because manufacturing cannot be done without mechanical engineers. Okay. In addition to that, I would also say that it is equally important for young engineers to think about entrepreneurship and become entrepreneurs, for which you need to have a variety of skills which the curriculum provides. Now, coming to your question as to whether mechanical engineering also provides you with programming skills, let me tell you that programming skills are fundamental to any branch of engineering. If you have to survive, and not only a branch of engineering, I think it is now a key to our very existence. Today, senior citizens have an issue because everything is on a virtual platform. And they have never looked at a virtual platform earlier. So you just need to adapt. Likewise, programming is going to become a key to every branch of engineering, and in mechanical engineering, the curriculum itself is ensuring that students become very good programmers. In fact, let me share with you that a professor from one of the most well-known IITs, when I had a discussion with him, he told me that, madam, on the IIT campus, the best engineers and the best programmers, he's a professor of computer science. He said the best programmers I have are from the mechanical engineering department. Okay, so yes, the curriculum is very, very alive to the fact that programming is essential, simulation is essential, and all these are being introduced in the curriculum. So if you join in, you will have the best of both the worlds. You will have knowledge of fundamentals, so you will have the breadth and depth of a core engineering branch as well as programming skills.
All right,
Yes,
as we
Vidhi.
wrap up this section, I'd like to thank Dr. Prasanna Nambiar for providing us with an insight into DBIT's Mechanical Engineering Department. I'd also like to thank Shashikant sir and Rajwade sir. And finally, a big thanks to everyone who attended this session. We hope you all found it helpful. Thank you again and have a good day.
Thank you everyone for joining in, and I wish you all a very, very bright future and excellent career prospects, whichever branch of engineering you choose to get into. Thank you so much.